When we first introduced the concept of IP addresses earlier in this section of the course, we mentioned that there was an IP version 4 and that there was an IP version 6, or IPv6 for short. Since IPv4 IPs are 32 bits long and use binary format, that means that we have two different possible combinations per bit. And if we were to do the math in order to find out how many total available IPs there are, we could do 2 to the 32nd power to represent two possible combinations with 32 bits. And this equals to roughly 4.3 billion IPs. While that sounds like a lot of IPs, we need to keep a few things in mind. As we've just discussed in a prior lesson, there are reserved IP addresses. Also, as you know, we can't use either the network addresses or broadcast addresses. So once you remove all of these, the usable IPv4 space is a little bit over 3.7 billion addresses. So that still sounds like quite a lot, but there are some addresses that will never be used. The reason for that is because when IPv4 addresses were first being allocated, large blocks were given to universities and several big companies. For example, some universities could have a complete /8, which allows for over 16 million unique IPs. Hardly any university will use this many IPs. So that's just one example, but again, the available number is actually much lower than 3.7 billion. Now on top of that, no one expected the internet to be what it is today. No one expected fridges and lights and doors and cars and whatever you can imagine connected to the internet. So even if you wanted to guarantee one public IP per person on the planet, that would not be enough. And frankly, one person needs way more than one device or one IP anyway. So this is why IPv6 was introduced and now exists. IPv6 addresses are 128 bits instead of 32. Now, maybe jumping from 32 bits to 128 bits doesn't seem like a whole lot at first glance, but let's do some quick math just to see how many available IPv6 addresses there really are. Since we still have two possible combinations per bits, and we now have 128 bits, we have 2 to the 128th power, which is around this ginormous number of 3, 4, followed by 38 zeros. I don't even know how to say that number because it's that gigantic. Now, just like with IPv4, there are some reserved chunks, but even after subtracting those, we're still left with about 6 octillion available IPs per person on the planet. So with IPv6, there is enough for everybody, including their devices, even their cells, and even their atoms. That's right, I'm not even kidding. Some people have done the math at the atom level. While everyone has a different number of atoms in their bodies based on different factors, including body size and so on, there is a comparable number of atoms in your body to the number of available IP addresses with IPv6. That's huge. Anyway, moving on from that interesting fact, let's take a closer look at the IPv6 addresses. According to the official documentation, an IPv6 address is written in 8 different groups of 4 hexadecimal spaces. Hexadecimal means that there are 16 possible characters from 0 to 9 and A to F, just like in a MAC address. And this is a very long way of writing down an address, but luckily there are ways to simplify it. For example, if there is a group that is all zeros in that IP address, it can be shortened with a : or a single zero instead. Now, following this rule, if you have several continuous groups with just zeros, you can also shorten them to these examples. Now, you can do that with the last example because since all of the zeros follow each other, it's possible to determine how many there are. But with this other example, you wouldn't be able to do that since it would be impossible to know how many zeros are represented by the colons. Instead, for this example, you could do this, or you could also do this. So again, these look quite different from IPv4, and that's very helpful in increasing the number of available IP addresses. Now, as we've said, IPv4 is still available today, and it's widely used today, in fact. While the transition to IPv6 is already happening, both are expected to coexist for a very long time. The fact of the matter is that it just takes a really long period of time to transition something so critical to businesses around the world. Now that we've discussed IPv6 and how it compares to IPv4, let's go ahead and complete this lesson, and I'll see you in the next.